Okay, so second hour, welcome. Today we are going to try to do a short virtual lab. For you guys, it's more of a video. And then I had two quick announcements, okay? My first announcement is tomorrow is actually Mr. Gallant's last day. So make sure you're in Zoom so that you can make sure and tell him goodbye and thank you for being with us this semester. He's done an awesome job, and student teachers, and tomorrow they end a week before us. So if you can make sure to be in Zoom tomorrow to tell them goodbye. And then also, second announcement, tomorrow we're gonna have a Parts of the Wave quiz. It will be a quiz through Schoology, but it's basically just labeling what we labeled on that paper, amplitude, wavelength, and I know you have your paper at home, so I'm okay with you using it, okay? So just those two announcements is during class tomorrow, we'll do a short quiz, and then it's also Mr. Gallant's last day. So we're sad to see him go, but we're happy for him. Okay, today we are continuing with sound waves. For a point for your group, who can tell me in the chat or on the microphone, what type of wave is sound? So there's two main categories, transverse and longitudinal. What type of wave do sound waves travel in? Okay, it's the other one. Okay, so Jaden, you get the point. What group are you in? I should know this by now. So Ryan, student teachers are only with us for a semester. So since it's the end of first semester, he'll be moving on. But maybe next year he'll be there as a full-time teacher. Okay, so group 6 told me. And then Jaden, what group are you in? Sorry, I missed it.
Group 1. Yeah.
Okay, so group 1 and group 6 got it. Guys, a longitudinal wave, oops, I just did the wrong motion. A longitudinal wave is when the way that the energy displaces the matter is in the same direction that the wave is moving. So remember I said picture like the speaker, and it has those little lines coming out straight in front of it. That's a longitudinal wave. Okay, so sound is longitudinal. It has to vibrate through an object. Okay, the way that we hear sound is a vibration of matter. Okay, so one cool thing that has to do with that are these. Okay, does anybody know what these are? If you looked at the name of today's lesson, you might know. Good, Elliot. Yep, group 3 gets a point. They are tuning forks. Okay, they're not a fork that you eat with, right? But this is a way that you can tune an instrument. So the way that these are shaped is supposed to give you an exact tone, an exact note, okay? And so when you need to tune your guitar, your piano, especially back in the day, they would do it using these, okay? So if we were in class, you could all annoy each other by making the sounds. I'm gonna try and see if you guys can hear this. Okay, do you hear like an annoying sound? Okay, it's way worse in person. So, but what musicians would do is they would make that exact tone and then, tune their instrument to match it. So today, instead of being able to do it in person, we are going to do a video lab, okay, or activity, and I'm going to share my screen. I was going to it without sharing. Okay. So everybody should be looking up at my board. In second hour science, or right over here in your upcoming, you'll see the virtual tuning fork lab, okay? Virtual means we're not able to do it in person, so we're just going off of a video of somebody doing this. But if you open it up and you open the Google Doc, you don't have to do it right now because I'm just gonna give some quick instructions and then I'm gonna give you time to do it. But you will see this. Okay, so up at the top is a YouTube link. Eventually, we're going to click on that. But first, I want to walk through this paragraph with you. Okay, So for 3 points for your group, who wants to read this paragraph at the top? You have to read it on the microphone.
I will.
Okay, sweet. Go ahead and read that first paragraph for us.
A tuning fork can give you a standard pitch. Musicians use them to tune their instruments. Most tuning forks have their pitch or frequency stamped on the handle. A tuning fork marked 256 gives off 256 vibrations per second and has a frequency of 256 Hz. This is equal to C on the musical scale.
Perfect. Thank you, Raya. Do you know what group you're in?
I think group 7.
Okay, group 7, 3 points. Okay, so when we talk about pitch, remember pitch is related to frequency. A high pitch sound has a high frequency wave. A low pitch sound has a low frequency wave. So that number, like 256, is the pitch of that note, which is also the frequency of that sound wave. So it says you try. Okay, you can either fill this in now with me or I'm going to post this later. A tuning fork, that should say fork, not four. A tuning fork marked 384 gives off blank vibrations per second. What would be the answer? If it's marked 384, how many vibrations does it give per second? Let's see in the chat. Okay, good, 384. Good job, Elliot. So if it's marked 384, that means it gives off 384 vibrations per second. Okay, and then we have this sentence, the blank of a sound wave determines blank, and the unit for pitch is blank. So we said that if it's high pitched, it's high frequency, right? So the frequency, and we might have to delete some empty spaces here because I was trying to make a blank for you guys. Okay, the frequency of a sound wave determines what? Okay, starts with a P. Who can tell us? Pitch. Good job. Okay, so the frequency of a sound wave determines pitch. That went to group 3. And the unit for pitch, right up here when Raya was reading, it's right up here. It's hertz, Hz, and that was also in our notes yesterday. Okay, so you will have to fill in those little blanks when you do your lab, whether you're doing it now or later. So it's the frequency of a sound wave determines pitch, and the unit for pitch is hertz or Hz. Okay. When we watch the video, you guys are going to be filling out this data table. It actually goes on to the next page because of my typing. He's going to have 2 tuning forks. Okay. Your job is to describe the tuning forks. One of them is short, one of them is long. They do have the numbers stamped on them. So like this one says 512C. In the video, you can see the number that's on them. And then we're going to listen to their sound against the table. On this one, you're just going to say high pitch or low pitch. And then, this is fun, because it's a vibration in matter, when he does the tuning fork, watch what happens when he puts it into water, okay? So I'm going to play the video. Okay, while this is pulling up, if you haven't opened your lab, it probably is a good idea just to open your lab. It's literally a 2-minute video, but he's
hey guys, Mr.
go
Reeves
through
here.
the lab.
So I want to do a demonstration of sound waves for you. And to do that, I've got these devices. They're called tuning forks. Each one produces a different frequency. Can you predict which one has the higher frequency? I don't know. Think about it. All right, let's try the little one first. So I'm going to bang it on the table, listen to the sound. Ooh, yeah, that hurts my ears from here.
You're welcome for that.
All right, and then let's try the bigger one. This one's longer. So what did you predict? Yeah, this one's the lower frequency. Okay, the longer it is, the lower the frequency. Remember, frequency is vibrations or pitch, right? Okay, you can do something really cool with these. I'm gonna take the bigger one. I've got a little bowl of water here. It's gonna get a little crazy. I'm gonna take this and I'm gonna hit it hard on the table. And I'm gonna put it in the water, watch. Oh, you see the water shoot all over the place? I'm gonna do it one more time. You can't see the forks moving, but when you put it in the water, you could clearly see the energy and the speed at which those forks are moving when it has that sound. So let's try the little one just for fun. Okay, here's a little one. Probably not gonna move as much.
Hold
Let's try
on.
it again. Whoa, that one worked good too. All right, hope you guys enjoy the video.
Okay, so when you go to fill out your lab paper, you might need to pause the video or go back to the video, and that is with this link right here. So I just clicked on it and then I could go to the thing. But before I let you guys go fill out the data table on your own, why did it make the water splash? Who can tell us? What do you guys think? Yes, it does, Dallas. Okay, why do you think the tuning fork made the water splash? What was it doing? What happened there?
I would think it was because it was like vibrating fast. So like
That's exactly
moving
right.
back and forth. Point two. It just
Good
moves
job,
the
Levi.
water.
Yep. What group are you in, Levi?
Group one.
Okay, I'm going to give group one a couple points for that. Good job. So we said that sound is a vibration through matter, right? So I'm not going to bang this because it makes that high-pitched sound, but when you bang a tuning fork, you're inputting energy. It vibrates that sound, and that same vibration is transferred into the water, which causes a splash, okay? It's very fun to do in person. However, since we're online, here's some questions to help you do the data table, okay? So in this one that says description of the tuning fork, you have two boxes. The top one is for tuning fork 1, and the bottom one is for tuning fork 2, okay? And your job is to, tuning fork 2. Okay, your job is to kind of answer these questions in those boxes. So is the tuning fork longer or shorter? And what is the frequency stamped on the tuning fork? It shows it in the video, but you might have to pause it. Okay, the sound against the table, basically, like I said, you're just saying in these boxes, is the first tuning fork high pitch or low pitch, and then splashing in the water. Okay, which one made larger splashes and which one made smaller splashes. So that should only take you a few minutes. I'm gonna hang out here in the Zoom, but what I want you to do, if you haven't already done so, pull up this paper. It's in your science folder for today. Click on the YouTube video again, and I want you to watch it and compare the two tuning forks, okay? When you're done with that, then you can go ahead and leave the Zoom. Jaden, you'll have to pause the video to see the frequencies. You'll see it, okay? All right, guys, so I'm gonna stop sharing. Mr. Gallant and I will be here if you